Now let us study the exponent of prime p in n factorial. That is, how to find the exponent of any given prime number p in the factorization of the number n factorial. Let's take one example so that this will be clear. Suppose we want to find exponent of, say, prime number 3 in the number 100 factorial. Now here, first of all, we consider all the powers of 3 which are just less than 100. So starting with 3, we have 9, which is a 3 square, then we have 27, which is 3 cube, and lastly we have 81. Of course, there are all the numbers in between which are also divisible by 3. So let us first of all concentrate on these powers. So we are marking these powers, and in between you can see that there are various numbers which are also divisible by 3. So I am just showing couple of numbers here, and then there will be number 99. Now to count how many times 3 is occurring as a factor in all these numbers, what do we do is, we first mark off all the numbers which are the multiples of, say, the first power of 3, which is 3 itself. So therefore we write 1 below each of the number, since all are divisible by number 3. Now to count how many such numbers are, we have to use the greatest integer function, which is nothing but greatest integer of 100 by 3, which is nothing but 33, because there are 33 numbers in 1 to 100 which are divisible by 3. So 3 is definitely going to occur 33 times. Now if we consider the next power of 3, which is 9. So if you consider the 9, in this number 3 is going to occur 2 times. So therefore if we mark off all the multiples of 9, which is 9, the next is, say, 18, somewhere here, then 27, and so on, what we will find is 3 is going to occur second time in these numbers, because they are themselves multiples of 9. Now to find out how many such numbers are there between 1 to 100 which are divisible by 9, so that is given by the greatest integer of 100 upon 9. Now let's go one step ahead, that is looking at the cube of 3, which is 27. So that multiples of 27, which is 27, 54 and 81, these are the only 3 multiples of 27 which are less than 100. So this number is actually nothing but the greatest integer of 100 divided by 27. And lastly, if we see the fourth power of 3, which is 81, which is the only number which is fourth power of 3, and there is no further multiple of 81 which is less than 100. So that is technically nothing but greatest integer of 100 upon 81. So now if we add up all these numbers on the right side, so the greatest integer of 100 upon 3 is nothing but 33, plus the greatest integer of 100 upon 9, which is nothing but 11, plus greatest integer of 100 upon 27 is 3, and lastly we have greatest integer of 100 by 81 is 1. So therefore this sum turns out to be 48. So therefore the answer is 48. So in other words, in the factorization of 100 factorial, the exponent of 3 will be 48. Now let us write the formula for this exponent of prime p in n factorial. So which is given by in general, the greatest integer of n upon p plus greatest integer of n upon p square plus greatest integer of n upon p cube, and so on. Now we have to continue this till greatest integer of n upon p raised to s. Now such that now this s has to be the largest number such that p raised to s is just less than the number n. So therefore here we write where s is the largest number, specifically integer, such that p raised to s is less than n, which is less than p raised to s plus 1. So basically what we are saying is p raised to s should be less than n, but p raised to s plus 1 is bigger than n. So therefore s is the largest integer. So therefore addition of all these individual numbers gives us the exponent of prime p in n factorial.